Hey guys, welcome to our second chemistry video, and today we're going to be talking about subatomic particles and what they are. So before we talk about subatomic particles, we need to know what an atom is. And an atom is the smallest unit of anything that retains its unique properties. And you might be wondering, well, there are subatomic particles, so obviously that can't be the smallest unit. But notice how I said that it retains unique properties. And I said this because atoms, let's take example of the one atom of carbon and one atom of oxygen. So these atoms have different properties. But these are the smallest unit which retains its unique properties, because an atom contains X amount of protons and neutrons and electrons. Therefore, there has to be a difference between each type of atom. Whereas for the subatomic particles, they're essentially the same. So one proton or electron or neutron from a carbon atom is going to be the same of a proton, electron, or neutron from an oxygen atom. And that's because all protons have the same properties, and that goes the same for the other subatomic particles. So now let's talk about the properties of these subatomic particles. So I labeled these subatomic particles as P, N, and E, and they represent protons, neutrons, and electrons respectively. So protons have a charge of +1 and a mass of 1 AMU. So AMU stands for atomic mass unit, and it's a unit of mass that's specifically made for very minute substances or very minute forms of matter, such as subatomic particles. So moving on, we have the neutron, which has a charge of 0 and has 1 AMU, or 1 atomic unit, 1 atomic mass unit. And now we have an electron. An electron has a -1 charge and is approximately 0 AMU. And I'm saying it's approximately 0 because obviously it can't be totally 0, or else it wouldn't exist. But it's very close to 0. And because it's very close to 0, it allows for electrons to be very fast. And that's why electrons are always moving. So as you can see in this diagram, we have these 3 rings. One of them I labeled over here. So this one ring shows the path of electrons. And electrons are always moving. Therefore, we can oftentimes, if we look at an atom at 2 different times, the electrons are going to be in different places. And that's why we use this ring. This ring is an accurate representation of the path of which the electron travels, and that's why we use rings in diagrams. And as you can see, the protons and neutrons are located inside the nucleus. So the nucleus is just a dense ball of protons and neutrons, which has a positive charge. And the nucleus has a positive charge because even though it contains neutrons, the neutron has a charge of 0, whereas the protons have a charge of +1. Therefore, there's nothing to counteract that charge of the protons, which is located inside the nucleus. Therefore, the charge of the nucleus is going to be positive. So now let's talk about what it takes for an atom to be electrically neutral. So atoms that are found in nature are already electrically neutral, and this is because the amount of protons in any atom is equal to the amount of electrons in any atom when they're found unaltered. And I'm using the word unaltered because Many times atoms gain or lose electrons depending on certain factors that we'll discuss later. And but usually when we find them at their raw form, they have the number of protons is equal to the number of electrons. And since the protons and electrons have opposite charges, they cancel each other out. Because we discussed how protons and electrons, they're an equal amount of each. Say we have positive x, and x represents the amount of protons and electrons, or protons. We also know that x is going to represent the amount of electrons because they're the same. The amount of protons and electrons are the same. Therefore, we can also use negative x to represent the amount of the charge and the charge of the atom of the electrons. So we have positive x and negative x. So once we combine these two, we get 0. And we get 0 because since we have positive x and negative x, when we combine them, we're going to get 0 since they're opposites. And let's just get a better example of this. Say we talk about the atom of carbon. Carbon now has 6p, or 6 protons, and 6 electrons. So the 6 protons contribute a positive charge of 6, and the 6 electrons contribute a positive charge of negative 6. So once we combine these, we get 0, which shows how these electrons have, how these atoms have a charge of, or how the atoms are electrically neutral. So what it means to be electrically neutral is that atom has net charge of 0. So let me explain this. So as you can see, it's electrically neutral, as we proved over here, because it has a net charge of 0. And a net charge just means the summation of all the charges in an atom, or in anything. So the carbon atom has a charge of 6, or plus 6, and the charge of the nucleus of the carbon atom is plus 6, and the charge of the summation of the electrons is negative 6. So when we combine these charges, we get 0, which shows how atoms are electrically neutral when they're found in their raw form. And that's basically it for this video, and thank you for watching. And for more content regarding chemistry, please like and subscribe to the K-Math. Thank you.